Hello everyone, this is Chenagala Sonith Yadav from Data Science, and this is a AAT concept video, and my topic is the series connection of capacitors. So what is a capacitor? A capacitor is an element in the circuit which stores electric charge. Say it again with me. A capacitor is an element in an electrical circuit which stores some amount of electrical charge for a temporary amount of time. So what makes a capacitor different from a battery? So what makes a capacitor different from a battery? A battery too stores electric charge for a long time. Let's let's see what happens. So the differences are clear. A battery stores energy in chemical format, and the capacitor stores energy in electric field. Whereas a capacitor has a low, how do I tell you this, capacity of storage, whereas a battery has more capacity of storage, and the capacitor charges and discharges way faster compared to a battery. But the capacitor, unlike the battery, the capacitor's main purpose is not to supply electricity throughout the circuit. Let's see how a capacitor works. So let's take a hypothesis here. Let's wait a minute. Let's ignore the let's ignore the tank right now. What Ignore the tank and this one right here, this pipe right here. So what happens when you there's a switch or like a wheel you can rotate, or so that you can turn on and off the water supply. So this comes with an infinite source here, infinite source right here, but you can turn it on and off the water whenever you want. So whenever you turn on the water just keeps falling down, and whenever you turn it off, the water stops coming. So that is what I'd equate to a battery. Whereas a capacitor is more inclined towards this whole diagram. That is, when the first source is opened, and it connects to a tank, and from the tank there's another connection towards another pipe with, through which water flows down. Through which water flows down. So irrespective of whether this pipe is turned off or on, the water from the tank goes through this pipe. So the water supply remains constant until the tank is empty. So let me explain to you again. That is, when you turn this valve on, water falls through this valve into this tank. The tank fills to a certain amount, and then you turn the valve off. Then when you turn the valve off, the water does not stop flowing through this pipe because the tank is full. Now that the tank is filled to a certain amount, and the water from the tank keeps flowing through this pipe. So this diagram is what I'd equate a capacitor to rather than a battery. A battery is just the first pipe. Okay, a capacitor is like a storage tank. It can be used to smooth out interruptions to the supply. So this is a perfect example of what a capacitor does. So we have an LED right here, a resistor, a battery, a switch, and a capacitor. Without a capacitor, let's imagine this diagram without a capacitor. Without a capacitor. So when the switch is turned off, the LED turns off. The LED turns off. But when you have a capacitor, the battery supply goes to the capacitor and a certain amount is stored inside the capacitor. So that when even if the switch is turned off through to a, even if the switch is turned off for a certain period of time, the LED still remains on. Let me explain it to you again. Capacitor is compared to a storage tank here. That is, that is, when you don't have a capacitor, when the switch is turned off, the LED light turns off immediately. But whereas when you have a capacitor, a capacitor stores a certain amount of energy that is transmitted through it, certain amount of electricity, not energy, sorry, electricity which is transmitted through it to the battery. And even if the switch is turned off, due to the electricity stored in the capacitor, the LED light goes on for a shorter amount of time, for a short amount of time before the electricity in the capacitor is totally consumed. So the capacitor acts as a stopgap of in circuits. So how does a capacitor look? These are all the physical varieties of a capacitor. And these are what they look in physics diagrams and engineering diagrams. So two parallel lines indicate a capacitor mostly, and these are all the different physical varieties of a capacitor. So the physical appearance of a capacitor. The capacitor unit is capacitance, which is usually measure the capacitance of capacitor in the unit of farads. Sorry, not capacitance. We measure the capacitance of a capacitor in the unit of farads. We mostly use microfarads because we do not have that amount, or how do I tell it? We don't have that much quantity of current a capacitor can store, like especially these micro ones. And this down here is the voltage rating for the capacitor. That is how much voltage it can store before it erupts. So this capacitor right here can hold up to 35 volts. That is, it can store up to 35 volts in it to supply it to the circuit before it bursts open. If you give it 36 volts, this thing will burst open. Okay, moving on. So here's the main topic: series connection of capacitors. Series connection is when they're connected in a straight line. So this is capacitor 1 and this is capacitor 2. It is equivalent. It is equivalent. These two combine to give C total, that is C equivalent. Once again, series connection of capacitors are C. This is C1 and this is C2, and these are in series. But unlike normal current, the formula for C1, formula for equivalent capacitance is almost as if it's almost as if when it is parallel in current. That is, C equivalent is equal to 1 by C1 plus 1 by C2 and so on up to Cn. So let's take an example here. For series connection of capacitors. So this is an circuit, for example. Sorry, yeah, this is wiring, for example. These three capacitors are in series connection: C1, C2, and C3. C1 is 0.1 microfarads, 0.2 microfarads, and 0.3 microfarads. So this is the premise. So how do we calculate the capacitance? How do we calculate the capacitance equivalent capacitance of the capacitors in series. So the formula is 1 by CT. CT is like the total capacitance. So 1 by Ct equals 1 by C1 plus 1 by C2 plus 1 by C3. So in this case, we had C1 equals 0.1 microfarads plus 1 by 0.2 microfarads plus 1 by 0.3 microfarads, which equals 18.33 into 10 power 6. So 1 by Ct equals 18.33 into 10 power 6. Therefore, Ct equals 1 by 18.33 into 10 power 6, which equals 0.055 microfarads. Thank you for attending this concept video, and